Hello everyone, welcome to our project of an IoT-based system that monitors the health of the baby. So this is a project of 3 people. There's me, Teresa Kantonga, there's Arthur Mwangonda, who is behind the camera, and there's Joseph Mwangisa, who is also behind the camera. So I'll explain what components we have and how the system is working, and then Arthur will take you through how we have sent data to ThingSpeak, our IoT cloud. So this system measures the temperature of the baby. It also measures the pace rate of the baby. When I say pace rate, I mean it measures the heartbeat of the baby per minute. We also have a component which is measuring the heart rate of the baby. And then we have a ultrasonic sensor which measures an object which is near the baby, which is maybe in a predefined length, which I'll tell you later in the video. So this is the ear creep heart rate sensor I was talking about. This is the ultrasonic sensor that I was talking about. And we also have the DHT11 sensor which measures the temperature, and we also have we also have this space sensor. This space sensor measures the heartbeat of the baby. So like for example, this ear grips sensor, it has to be attached to the ear of the baby, but in this case I'll pin it to my finger. So as I've pinned it here, it's taking the readings of my heart rate, and this is displayed on our OLED display here, so you can see the heart rate is changing. And when it's in normal range, the blue LED blinks as it is blinking here. Okay, thank you. We also have this pace sensor. This pace sensor measures the heartbeat of the baby per minute. So I'll place it here. It's an optical sensor. It uses light to detect the difference, and then measures, convert the difference into an electrical signal, which is displayed as a digital pace rate. So this is also displayed on the LED. As you can see here, on the LED it's displayed. Yeah, thank you. We also have the DHT11, which is displaying the temperature, which is measuring the temperature. So like in this case, it's measuring the temperature of the environment, but we want it to measure the environment, the temperature of the baby, and this is also displayed on the LED. And then we have the ultrasonic sensor. This one measures the distance which is of an object near the baby. So it's it uses the ultrasound waves to measure the distance, and then it converts that wave into an echo, which is then reflected. And when that distance is detected, when the object is lying in the predefined distance, which is 1 to 1.5 meters, the buzzer produces some sound. This is our buzzer, and the LED LED turns on. So the buzzer produces some sound to alert the guardian that something is near the baby, and the LED to signify that there's danger near the baby. So I'll stand here so you can see how this is working. Of course, it takes a little some minutes because this sensor is sensitive. Let's just wait for some minutes and then see. Oh, okay. All right. Oh, there you go. Now it has detected that something is in the range of 1.1 to 1.5 meters, and then it produces some sound, and the red LED turns on to signify that something, some object or some danger is near the baby, so that the guardian can take an action. So for this sensor, the heart rate sensor, this one, it captures like the measurement of the heart rate, the electrical signals of the heart in every 20 seconds, and this gets accumulated, and then after those 20 seconds it gets the average or the readings, so that it can get an approximate reading of the heart rate. And all this data that we are monitoring here, that we are measuring here, is sent to ThingSpeak in the cloud. So my friend Arthur Mangwanda will take over from here to explain how we have.
Thank you very much, my colleague Teresa, and our colleague Joseph Mungisha. And I'm Arthur Mangwanda, as my colleague said. I will take you through how we have sent the data from the from the sensors to ThingSpeak. We have used the nodeMCU, and we have used GSM to send the data through FMS. So, but that one is not working properly. That's why now we focus on the nodeMCU, and we have used the nodeMCU ESP32. So, as my colleague, as we can see, this is the nodeMCU which we are talking about, but it's the ESP32, as you can see inside. It's different from the nodeMCU ESP 8266. So we have taken the same, this one is the GSM module which we use to send the data to through SMS to the phones, different phones. And here we have different sensors, as my colleague said. So we are taking the same data from the sensors and they sent through to ThingSpeak through nodeMCU, ESP32 nodeMCU. So this one is the data which we are collecting from the sensor. So this one is the temperature which we are collecting from DHT 11, and this one is the heart rate which we are collecting from ear creep heart rate sensor, and this one is pace rate. We are collecting from the pace sensor this data, and this one is the distance which we are collecting from ultrasonic sensor. So ultrasonic sensor is measuring the distance. That's why it's like overlapping here and there if someone just goes down. So that's why we are getting that. I will just go through a little bit. This one is the ESP. That's the data which we send through ESP. Yes. This one, and it's the data. It's the code which we have just uploaded into the Arduino Uno 3, and that the other one we have uploaded in the nodeMCU ESP32. Yeah. Thank you very much for your attention, guys. This is how our whole system is working. Thank you.